Hello everybody. My name is Murat Sultan, and I'm gonna show you math group assignment question number 1. Question number 1 consists from the table and from text, blah blah blah. And I'm gonna represent for you what's the question about. This question about how it was changed about boundary manual law. But is it necessary for us? I think not so. It's necessary for us is the carbon dioxide emission level of data. So I'm gonna talk about the statement of the question, which requires from us to use the linear model. And what's the linear model? To clear understanding of that, I'm gonna show you it by the graph. Our graph: carbon dioxide emissions levels in the 1987, in the 2005, and when it's gonna exceed the 400 carbon dioxide emissions. So what we're gonna use? We're gonna use linear square method, and we have two data which are needed for us. So it is years, which represented in X, and carbon dioxide level, which represented in Y. So I'm gonna show you formula in the desk. Which is equal to summary of the difference in the years and difference in carbon dioxide levels. And everything divided to this about how to explain. Now, as you see, it is our data is not energy. We will not so we can and we get the equation more easily. So, what does the letter means? Who knows? Until I explain. The M means slope. Slope is the relationship between the carbon dioxide levels and the difference of the years. And the second one shows us how it will be changed. Difference in the carbon dioxide, which is dependent to X. And the X. Difference between X means years. Difference in years. So, according to the data, we can see that the data is constant, which means the slope between them, what we're going to find, it's always constant too. So we can easily say that M, the slope, is a constant. And now the next step in our equations, in our calculations, I'm gonna do Gurbanov as is.
Hello everybody, today I'm going to calculate the given equation. We are given CO2, we have to find CO2 level in the year of 1987. Before finding the CO2 level, we have to find the slope. And we have this formula. With this formula, we can find our slope. And I will write M. M is our constant. I will write Y initial is the data of CO0, and our Y initial is 300. And now we can find our CO2 level in the year of 1987. As you know, M is as our friend Sultan said, M is our constant. I can write this as 8. Using this formula, I can find my Y final. Our one is okay, nice. As for now, so we can find 19, so now it's initial, and we can use 1987. By using this, we can find our Y final. And our Y final will be 349.155. I can write this here. So next question, we are required to find the CO2 level in the year of 2005. And also it's the same formula. We can find it with this formula again. Our M is question also asks us to solve it in the opposite direction. Now, we are not given the year, but we are given the CO2 level in 400, and we have to find the year. And it's also the same. You can find it by using that formula. We are given 5 lines, 4 lines, 2 lines, so we have 5. And now it's done. Only 2021. Here. And question 1 is solved. Now I will give the second question to my friends, Abbas and Ashraf. Thank you.
Okay, so next question is question number 2. So here we have a cone and we have some information. So we have a volume of water which is increasing at the rate of the 30 centimeters cube per second. Okay. Then another information we have is the radius, which equals to 10 centimeters. Then lastly, we have information about the height, which equals to 10 centimeters. So the question asks from us to find the rate at which the water level is rising. Okay, when the water level height is 10 centimeters. So we have to find the change of the rate of the volume when change of the height with respect to the time. Okay, at the 10 centimeters of height. So in order to find that, we have to come up with the relationship between them. So this relationship comes from the volume of it. Okay, so the volume is 1/3 pi r squared multiplied to h. Okay, in order to find the relationship, we have to understand what R is, because we have two unknowns, which R and h. So we have to find the R in terms of a hash in order to have this terms of relationship to time and to the volume. So how are we going to find it? Okay. So if you can see through the figure, we can see that there's some sort of similarities. Okay. If you're going to draw this, the triangle, which is, we can see big R, big hash, and we also have little r, little hash. As we know that the angle, it should be a right angle when it comes to height and radius, and similar to this, and also we can see they have similar angles, the common angles, and equal angles from rules of the geometry, parallel angles. Okay. So from this rules of geometry, we can say that the ratio is hash to r equals to little hash to little r. So our hash is 20, our big R equals to 10. Then we have a hash divided to r. So this equals 2, this gives us 2. Then when we multiply 2 to r, we have 2r equals to hash. But we have to find r, right? So we divide both of the sides to 2, then we have r equals to 1.5 hash.
Now we have the r equals 1/2h. Now we can plug it in the volume equation. So we have V is equal to 1/3 pi 1/2 h square h, and 1/2 h square is just 1/4 h squared. So you get 1/3 times 1/4 is 1/12 pi h cubed. Now we're going to find the derivative of v in terms of h. So we have dv over dh is equal to, the 3 you bring in front, you get 3/12, which is equal to 1/4 pi h squared. And now you want to find it when the when the height is 10 centimeters. So when height is equal to 10, the dv over dh is equal to 1 over 4 pi 10 square. And 10 square is just 100. So 100 over 4 you get 25. So dv over dh is equal to 25 pi. Now how are we going to find the dh over dt? Well, you can say that dh over dt can be equal to dh over dv multiplied by dv over dt. This works because the dv and dv can cancel out each other and you get dh over dt. So dh over dv we can take from here and we can flip the equation, so we get 1 over 25 pi multiplied by dv over dt is just 30. So we get 30 and it's equal to 30 over 25 pi, and you simplify, you get 6 over 5 pi centimeter per second.
So my name is Tokyola Vidmir.
Yeah. My name is Stella.
Today we'll be discussing a model of blood flow. The derived velocity of blood flow from the distance model is given below. The distance traveled by blood at time t can be modeled as dt equals to 20 plus 5 sin 7.85 t into t. dt represents the distance traveled by blood at time. The term 20 plus 5 sin 7.85 represents the velocity of blood flow, and the constant 20 centimeter per second, which 20 represents the average velocity of the blood flow, and the component 5 sin 7.85 t, which models the rhythmic variation in blood flow velocity due to the heartbeat. And for this equation, dt equals to 20 plus 5 sin 7.85 t into t. To find the velocity, of this model, we will be using product rule. And the equation for the product rule, basically we have to differentiate this equation to find the velocity of the blood flow, and we are using product rule as a differentiation method, which is u into dv by dt plus v into du by dt.
Okay. So in the beginning we need to find our component, which is u. U is equal to 25 sin 7.85 t, and v, which is equal to t. So to find our dv dt, we need just to differentiate our t, which is 1. So to find our du dt, we differentiate our u. So 20 is a constant and getting 0. From 5 sin, we getting 5 cos 7.85 t, and after differentiation of this term, we getting 7.85. So our du dt is equal to 39.25 cos 7.85 t. So after finding our terms, we need just to sub it into our product rule. So u equal to 20 plus 5 sine, we multiply by 1 plus t into 79.25 cos 7.25t. So the next steps we multiply it and getting this equation. So our final answer is 20 plus 79.25t cos 7.85t plus 5 sine 7.85t. So the velocity of a blood flow is here. Thank you.